My name is Manuvir. As she mentioned, I've spent the last 3.5 years working on this project, which we first codenamed Red Dog from its very first days. So what I thought I would do today is show you a little bit of what this platform is and what it can do, but more importantly, why we built it and what the philosophy was, because I think that will shed a lot of light into how you may or may not use it for your own purposes. So I think before we even start with Windows Azure, I'd take a couple minutes to talk to you about the cloud. I know this is a buzzword that is pretty much everywhere these days. Last week I was interviewed by somebody who's a VJ with MTV, and he was asking me about the cloud. So it really is everywhere, right? So I'm going to make an attempt to define it for you to set the context. Please note this is my definition, and I'm sure every person has their own. And I'll try to approach it fairly mathematically for you. So I think as a computer scientist, I think of a cloud as nothing more than a set of servers that are wired together through a network and that are reachable from somewhere else through the network. And what's interesting and different about the cloud is the fact that you're not talking about 3 servers or 30. You're talking about tens of thousands of servers that are all connected together running your application. And in addition, because there are so many servers, and because the customers who are reaching the service that is running on these servers are so widespread, these networks are typically geo-distributed, right? So some of your application may be on one continent, some might be on another. We've had things like clouds for many years, right? For many decades. We've had supercomputers, all kinds of machines that do heavyweight computation. I think the fundamental thing that's different about the cloud compared to some of those systems is the fact that all the hardware is commodity, right? Every server that's in these data centers is no different from the server you can walk into a local store and purchase. Literally, they cost $1,000, a couple $1,000. Whereas in the old days, when you had these big systems, it was just the opposite, right? People were paying millions and millions of dollars for these machines, and they were engineered to never fail. These machines fail all the time. These are like the disk drives in these machines are no different from the disk drives that you have in your PC sitting in your house. And then finally, the other interesting thing about the cloud is that it is really accessible from everywhere, right? So the services or applications that you're hosting on the cloud are expected to be up all the time, because there's never a time when your customers are all sleeping, right? If you've got a photo sharing service, if people in India are sleeping, then people in the US are awake, and vice versa. So that's how I think of a cloud. Now, what is the cloud, right? People say the cloud, I'm going to the cloud, right? I think the cloud is just a term or a moniker for all of these clouds that are sitting everywhere in the world, right? There's many different cloud providers, different companies that host clouds. There's a lot of big businesses that have had their own clouds for a long time. They've had their own IT infrastructures, right? So the cloud is just all of these, and when you talk about going to the cloud or developing for the cloud, you're just talking about running an application in an environment that has these characteristics, right? It may be hosted by a big cloud provider. It may be hosted by your own company, okay? So that's a quick 2 minutes on the cloud. Now, I think what's interesting about the cloud and why so many people talk about the advent of the cloud is that it offers an opportunity for a wide variety of people, right? I think for businesses, there's the attraction that, hey, we can get rid of our IT infrastructure, right? We don't have to host anything. We'll offload the hosting somewhere else. We'll move our workloads to the cloud. But I think it's important to note that this is only the beginning of the cloud opportunity, right? The real opportunity in the cloud is not so much moving your infrastructure somewhere else, because at the end of the day, it's just hardware. You can host it here or you can host it there, right? There may be some economies of scale for the cloud providers, but at the end of the day, it's just a matter of hosting your hardware. I think the real opportunity for the cloud is the way applications are designed and built in the cloud. And if you look at those applications, they're far more manageable than the kinds of applications we're running today. And so what that does for you is it can really reduce the cost of managing and operating these applications. And that's where I think the real win for the businesses is and is going to be, okay? For consumers, clearly the win here is that because developers can spin up these applications in the cloud, it really empowers consumers, because now you can get access to all kinds of information that you could never get access to before, right? Things like Facebook, I mean, are amazing in terms of what they've done for consumers. And of course, Facebook is just running on the cloud, right? And then I think for this audience, as developers, of course, we're looking for opportunities all the time. And I think the opportunity for developers here is there is really a new paradigm that the cloud is bringing together. I'll talk about this. And anytime there's a new computing paradigm, there's an opportunity for the developers to jump onto that bandwagon, if you will, get on that paradigm, build new applications, help businesses migrate their existing applications, take applications and make them more friendly towards the new paradigm. And that should open up a whole range of opportunities for the developer community for many, many years to come. Okay? The unfortunate reality is that the cloud brings with it a challenge, right? For businesses, people who are putting their applications in the cloud, the real challenge here is you're offloading your stuff, and you have to trust the people who are running your stuff for you now, right? Which might be your application, and in particular your data, because the data might be private, it needs to be secure, etc. And equally importantly, you have an expectation as a business that your applications that are running always run, right? They never fail. And that's something, again, you're entrusting to both the cloud provider as well as the developer of the application, okay? For developers, actually the challenge is really significant because it turns out it is very difficult to build applications that function 24/7. And because it's so difficult, what happens is every time you want to add new features to a service or develop new functionality, even though you're living in a world where the customer's expectation is that you're agile, because in the services world you roll out things very quickly, right? How often do you think Facebook updates? It doesn't update once every 3 years, right? It updates once every 3 hours probably, or even less. So on the one hand, that's what the customers expect, but on the other hand, this environment is very difficult to operate in. So I have a slide for you as to why that is. So imagine that you're a developer building a cloud service, and if you just think about the set of activities that you go through on a daily basis, right? So the first thing is you have to have some place to run your service. Today there are data centers, and you can rent out hardware in data centers. The hardware is going to fail, right? As I said, this is commodity. When you have thousands of servers, it's guaranteed that some disk drive, some router, some top-of-rack switch is failing at any moment. It's just a given. It's going to happen. So you have to deal with those things. If your service is popular, you're going to see more traffic. You have to scale up to handle that. When you do that, you need more storage capacity for all your customers. Your service is going to fail on occasion, and you have to find a way to diagnose that when you're running on thousands of machines. The operating system has to be patched every time there are security issues. Once in a while, you actually get time to add new features, and you have to bring those features online without taking your service down. You have to move into new locations because your customer base is spreading, right? So there's just a litany of these things that you have to go through on a daily basis, and then you're left with a little bit of time to actually work in business logic, right? So this is the conundrum of the cloud. On the one hand, it opens up this opportunity. All your customers want you to be there and build these agile services, but on the other hand, there's something that's missing that would take care of all of these things for you. And so as a developer, you actually spend a lot of your time working on this stuff. And that's why I believe we need a cloud platform. That's why at Microsoft we started building a cloud platform, which is called Red Dog and is now called Windows Azure, right? So this slide is to share with you sort of our vision and our belief as to what is it that the cloud platform should have to truly solve the problems I showed you in the previous slide, right? To make development more agile on the web. The first thing I would say is, if you think about what an operating system does for you as a developer on a single machine, right, on a desktop or a server, it provides you certain facilities that you take for granted so that you don't have to build them in. Think about how you run an application on a desktop or a server, right? You just hit the name of the application, write the name of the application, and you hit enter, right? You don't think about where should I load this, which memory chip does, which hex address do I start off from, etc. There's a thing called a loader that is built into an operating system. Whereas if you think about operating services in an environment where somebody gives you hardware, these are the problems you deal with every day, right? Which set of machines should I run on? Where should my front end be? How do I start it up, right? This should all just be given by the cloud platform. The second thing is, this is the world of utility computing now in the cloud, right? You want to pay for what you use. It's a rental model. You expect 24/7 operation. System should never fail. And everything should be simple to administer because the scale is just amazing, right? You're dealing with thousands of machines. So that's the other aspect of the cloud platform. And finally, the platform is not complete unless it comes with it a set of services that you can rely on. a couple of services you heard about in the previous talk, right? But databases is a great example, right? How many people use SQL Server or databases provided by another vendor as a key part of the applications that you build, right? You need those kind of facilities, but you need them in the cloud. Okay, so a quick summary of what's in Windows Azure should follow directly from the previous slide, right? It's a system where you get flexible application hosting. We have thousands of servers across the world where you can host your applications, both new kinds of applications that I would call cloud-friendly, that are built in a certain way, as well as legacy code, right? Because we're always going to have legacy code in this world, right? I think it's important for the cloud platform that beyond just providing you resources to run on, it should really drive, encourage, and push you towards the right programming model for the cloud, right? So Windows Azure comes with a built-in programming model that I'll share with you in a minute, and it's an integral part of the platform. And the platform actually uses that programming model to maintain the health of your service and to drive down TCO, right? And that's a core part of the platform. I'm at Microsoft, so I'm biased in saying that everything should always come with a rich developer experience, a set of tools like Visual Studio, etc., nice wizards, all of that, so that what you would do in 2 hours, you can do in 2 minutes. Because we believe in reducing TCO in the cloud with this programming model, we've built into Windows Azure a concept of lights out service management, where basically you don't think about your servers or where stuff is running. You just provide your application, and the system figures out where to run it, how to run it, etc. Okay, and finally, the platform comes with storage at massive scale. Think of like having a file system that's in the cloud. But what's different about this file system is it can store petabytes and petabytes of data. Each customer can have as much data as they want. Each of your files can be as big as it needs to be, because there are no physical limitations in the system, such as, you know, all of your file is going to be on one physical server. It doesn't work like that. Everything is broken up into pieces and spread across servers. Everything is replicated at least 3 times so that your data is never lost, right? That's the idea of this system. Okay, how do developers actually get access to Windows Azure? There's a portal where you sign up. There's a service that we run in the cloud for service management that basically takes all your applications and spreads them out. Across the world, we have a number of data centers where we have storage and compute clusters, if you will, where you run your application. And the compute clusters are basically divvied up into VMs. So everything in our environment is virtualized. Your applications are running within virtual machines that are not shared with other applications. We give you a set of tools that you use on your desktop to build your applications. The tools come with a complete simulation of the cloud. So literally on your desktop or on your laptop, you can build your application. You can say, I need 10 instances of a front end, 3 instances of a back end, 5 instances of a database. Launch it on your desktop. Your whole application will spin up with all these instances. You can run it and debug it right on the desktop, see all your concurrency issues. Then when you're ready to deploy to the cloud, you just make the call to deploy. Exactly the same bits are pushed to the cloud, and then it runs over there. Okay? If you peek inside one of these virtual machines, what we've got there is basically, it's a VM, but we've got a little bit of code in there that is helping to manage the environment for you and maintain the health of your service. And then, of course, there's your code that goes into it. So I talked about the programming model of Windows Azure. So let me take a couple minutes to show you a slide of what this programming model looks like. So the idea is you have a service that you define. It's in a box of isolation. Nothing from the outside can look inside your service. Within the service, you break up your architecture into a number of roles, web roles or worker roles. Web roles are basically things like ASP.NET hosted under IIS. A worker role is like any old executable running with a main. Okay? For these roles, you can define these things called endpoints, and then you can wire up your endpoints to the external world through these hardware load balancers that are provided by the system. And all the load balancing is done for you by the system. The whole storage service, you can think of it as a bus that your application is sitting on, and it provides a number of abstractions like blobs, tables, queues, databases, and your application and other applications can communicate with each other through this bus, right? Now, you'll notice that for any of these roles, I've shown you multiple copies. So the basic model in Windows Azure is when you create a role, which is really a piece of code, like your ASP.NET front end, or your Java front end, or some C# code you have in the back end, you can ask for any number of instances of these. And the system will create for you identical copies of this code on individual VMs. It'll start up all those copies of code, and it'll wire up all the load balancers for you automatically so that the traffic gets distributed for you. Okay? And all you specify is how many copies you want. And as you need to scale your system up and down, you just change the number of copies you have. So this is the cloud-friendly programming model, right? It's scale out because it's commodity hardware. You're running on 10 of these VMs for your front end. 3 of them might fail, right? You don't want your application to go down when that happens. Windows Azure monitors all your roles. And if that actually were to happen, it automatically restarts your roles. If a role crashes, it detects that and restarts that. It does that a number of times. If there's a problem with the VM, if the disk has gone bad or something like that, Windows Azure detects that, finds another VM for your application automatically, brings up your application in that VM, rewires the load balancers, etc. All this is happening in real time, right? So your application can remain healthy, and you can continue on developing new features, okay? So the service management, basically, we have this world now with Windows Azure, with these facilities I talked about, that you can truly develop your applications in a way where you just write your application code and build the service model that I showed you in the previous slide, and then you're done. The system will do all the resource allocation, figure out where to find what, and get you up and running, right? And the part of the platform that makes this happen is what we call the Fabric Controller. That's the secret sauce. It's watching your applications, doing healing for you as things fail, right? So just one slide to answer the curiosity about the Fabric Controller, and this is really my last slide. The way this thing is implemented is the Fabric Controller itself is a service that we run throughout the world in all our clouds. It's designed, we spent years building this thing so that it's highly available, it never fails. Now what the Fabric Controller does is it has control over all the physical servers in our data centers, and it talks to them in 2 ways. It's got a direct channel, which we call hardware control, so that it can boot up these servers remotely, PXE boot them, etc. And then it talks to these machines through the LAN, so that it can communicate with the agents that we have sitting on all these boxes. So you deploy an application, the Fabric Controller figures out which servers to allocate them to which VMs, it communicates with its agents, it says start these up. Imagine that a particular instance of your role fails, right? As I said, we detect that. The Fabric Controller talks to the load balancers. The agent will tell the Fabric Controller, you know, that piece of ASP.NET code is failing, it should not get any requests. That message comes back to the Fabric Controller. The Fabric Controller communicates with the load balancers in real time and takes that server out of rotation, right? All of this is done automatically by the Fabric Controller, and that's why I call it our secret sauce, right? So that's a little peek into what's inside Windows Azure. So that was a pretty quick run through of this system, but I have one slide of summary that I think is what you can take away from this talk. I think for businesses, really the most important thing about the cloud, it's not about outsourcing hardware or finding resources. It's really about reducing TCO. That is the promise of the cloud, whether it's realized today or 3 years from now or 10 years from now, right? And then for developers, the key challenge and opportunity for developers is that in this environment, dealing with scale is very hard. And the developers who figure out how to do that well are the developers who will win. And the cloud platform that makes it easy for developers to do this, in my opinion, is the cloud platform that will be here to stay, right? And I really think that when we built Windows Azure and Red Dog, that was our goal, right? To build such a platform. And you are the jury, right? You will use this platform and decide for yourselves whether it actually meets these goals or not, all right? So anyway, that was my spiel. Thank you.